Okay, the last kind of thing we want to talk about that we can use to describe functions is asymptotes. And I think by now you've already heard about asymptotes in previous math classes. So hopefully this is just a reminder. But an asymptote is when the function starts to look like a line, like a straight line. And there's two different kinds of straight lines that we're going to talk about in this class, and that's vertical asymptotes and horizontal asymptotes. And there's kind of particular things about each one. So we'll start with vertical asymptotes. So a vertical asymptote looks like what I've got down here, what I'm drawing. It's just like a straight vertical line, and the function starts to resemble that. So I've got a line here. The function value, so the height, approaches plus or minus infinity, or both, as in the case in this picture, as x approaches a value not in the domain. So this isn't always the case, except in this class it's pretty much always the case. There are functions that don't follow this rule, but we pretty much are not going to talk about functions like this. So notice in this picture here at -4, there's never a time when the line gets all the way to -4. It gets closer and closer and closer, but it never does. So at that point that isn't defined in the domain, it shoots off to infinity in both directions. It looks like a straight line. That's a vertical asymptote. For example, I've got this function, and it's not graphed, 1 over x minus 2. Oopsie doops. And it doesn't exist at 2. See, you can. I already wrote that in. Oopsie doops. It doesn't exist at 2, and that's because 1 over 2 minus 2 would cause you to divide by 0. And that's bad. We don't divide by 0. When we divide by 0, it causes a vertical asymptote. Or in this case, it caused a vertical asymptote. Horizontal asymptotes are just a tiny bit easier. The function approaches some value as x approaches infinity, so it's kind of the opposite. So down here, as x goes to infinity in this direction, the graph starts to look like a horizontal line at y equals 6. So I feel like that's much easier than a vertical asymptote. The function's graph becomes closer and closer to a horizontal line. For example, a of x equals 1 over x minus 2 plus 4. Well, so this one, we already know that you can't divide by 0. So at x equals 2, there has to be a vertical asymptote, but there's also a horizontal asymptote at y equals 5. And that's because of this plus 4 and this 1 here. If you are not super familiar with rational equations like this, that's okay. We'll get used to it in time. So let's do 2 examples really quick. So this is a graph of g of x, and it's equal to 2 over x plus 4 plus 6. So what are the asymptotes of g of x? So as I go to the left, this starts to resemble y equals -6. And as I go to the right, it starts to resemble y equals 6. So there is a horizontal asymptote at y equals 6. And then vertical asymptote, there is one right here. It resembles a straight line in both directions. And that's happening at x equals -4. So then there's a question, does f of x have any asymptotes? If so, what are they? So let's go back up to what f of x is. All right, so this is f of x here. So I think I have been drawing this like it's going like this. And if that were the case, then there are no asymptotes. But I could draw it differently. So if I drew it like this, and I just made it like that, yep. Yep. Then I could say, yes, there is a horizontal asymptote. But I haven't really given you enough of a picture of the graph for you to really answer that question. So I'm going to put down at the bottom, need more information. Okay, if you have any questions about asymptotes, let me know and I'll find you more information.